Okay. All right. I think we're doing good. I think we're getting there. Let's see. Still, am I up? Am I live on the YouTubes? I think I'm live on the YouTubes as well, and on the Twitches. I think we are doing good. Awesome. Okay. All right. So with that in mind, we are ready to get started. This week could be a little interesting. I kind of flubbed and didn't do some maintenance on some of my equipment, so we'll see how that goes. Could run out of battery on my camera. Could run out of battery on something else. We're just gonna run through it and see how it goes. So, excuse me, crap. With that in mind, let's get started with this week. And that's going to be with adding Tokio to our application so we can get concurrency in our scanning of our network. If we get through that pretty quick, we are going to go over into saving off the data and into the database. And if we get through that, I'll be amazed. So let's go ahead and work on getting the next part going. The idea is that we want to be able to scan everything really, really fast, get the result back, save it to the database. And kind of the idea is I want to be able to run this application regularly and just constantly keep updated information about what is on the network and when. And so that way, let's say I update it every 30 minutes or every hour, all I got to do is run the command in order to say, hey, what is all on my network? And it'll just hit the database and tell me because that's good enough. However, I want to be able to force a new check in case I plug in. So let's say I have a Raspberry Pi. Normally, yeah, right here. Say I have a Raspberry Pi, I plug it in and add it to the network, and I now need to know what the IP address is on that. All I got to do is run the command, and it shows me force it to go ahead and do a scan, and it should show me the new IP address that's on the network. That is the goal of this project, is to be able to plug in new things onto the network and be able to find them so I can access it over the network. So with that in mind, let's go ahead and see about getting Tokio going. The other goal is to kind of learn how to interact with the system, learn Rust, and ultimately get closer to systems programming with Rust. So anyway, let's get going. And the first thing that we need to do is we need to install Tokio. So we're going to do cargo add Tokio. Now, I don't know if I need any of these features. Could do cargo info Tokio, cargo info Tokio. Yeah, no, didn't think I was gonna be that lucky. We'll see what we need as we move in. So I know since we're doing async, we're gonna have to do some stuff to set up the main as running a loop, and then we're gonna have to tag some stuff anyway. But that's what ChatGPT is here for, to help us work through some of these issues. All right, you know what? Let us. Yeah, no, keep on. I am going strong with my Rust application. I'm gonna pat myself on the back with this one. Uh, Now I want to integrate Tokio. Uh, okay, I prematurely hit enter, and so we're going to see what happens. Integrating Tokio into REST applications is great, especially if you're building something that could benefit from asynchronous programming like IO-bound applications or services that perform many concurrent tasks. Here's a step-by-step to get started with Tokio. Oh, that's cool. Let's do cargo add Tokio feature equal. I have no idea what I'm doing. Full. Cargo add help. So something you just gotta kind of keep. Oh, features. If I do ers plural, you just gotta keep working at it. Cargo add. I mean, this is actually interesting. So if we'll cat um, our cargo.toml file, uh, yeah. See, we have Tokyo. Uh, huh. I don't have it. All right. Okay, let's go back. So we have Tokyo. We don't have any features. So let's do the cargo add Tokyo features, and we'll do full. Not all. Apparently my F doesn't work. There we go. Okay, so now it's gonna delete all of that it added. I don't know what the Mio is, but hey, the MIO. All right. Failed for the slide. The satisfies dependency. You're looking for the pre-release package, dude. But okay, we're not really there. All right, cat cargo dot toml features full, and we're at the current version. Cool. So it added it retroactively. Would that be the word? Okay. Cool. We have it in there. Yep, this is the thing I was after. We need Tokyo main for that, and it's got to be an async. And yep. All right, let's just read it because I know what it's doing, but let's be explicit here. To run async code, you need to async runtime. Tokyo provides this in your main.rs file or wherever your application entry point is. You'll set up the Tokyo runtime. Use the Tokyo main macro on your main function to automatically set up the runtime. If your main function needs to do synchronous work before running the async code, you can manually create a runtime instead. So there we go. Now you can start converting your code to async or writing new async code. Here's a simple example of making asynchronous function with Tokyo. So async fetch data, Tokyo sleep, just to act, and then we're gonna do a fetch data dot await. It's gonna mat if let, yeah. Okay. So we're gonna learn by the school of hard knocks. So out of curiosity, let us, so we're getting the hosts. Okay, get host. So yeah, this is a sync, and then so the get IPs is the part where it's based on a CIDR rule pulling back the IP addresses. Just an FYI, if my camera here goes down, I don't know. It's warning that it's kind of maybe out of battery, so I don't know what's going to happen. We'll see. Anyway, it doesn't really matter. Let's go with code. Code is what matters. All right. Okay. Sorry, I got distracted by something because I wanted to make sure everything was going okay. So let host equal host. Yeah, okay, so this is where it's pulling back host data. This is where it's pinging the host. So it's okay, so it's looping through, it's building up a host piece of data, struct, object, whatever. It's doing the ping, it's doing the ARP. So, and then if the MAC address is none, and the host notes is none, notes will be a later thing. Then we're adding it to the list. Okay, yeah, we're gonna have to restructure this to do async calls. Yeah. Ooh, I think if the camera goes down, the mic might go out. So, because I don't have this, we're gonna play this by ear. Hopefully this goes well. Kind of nervous. Please last, please. Okay, so let mutable host vec new. Man, okay. So get host doesn't actually need to be asynchronous itself. What it calls, yeah, because like it can call this asynchronously. For some reason, like my shortcuts aren't working. What in the world? Okay. Why? Okay, for some reason my Vim isn't working right. Let's look at this a little bit. Update. Already up to date. Mason. Rust analyzer. Update that. Not that that's no, we'll go ahead and update Pyrite, who cares? Ooh. Let's see. Pattern not found in C++. Oh, okay. I don't. Something has gone nuts with my thing. All right, let's. Okay, I don't know what's going on. Okay, whatever. We're good. We're better now. I need to figure out why it all broke later. All right, so we're gonna do a ping. I don't know. Do that. Yep, battery just went out. Uh, is it still? Is the audio? How is the audio still working? What? Okay. Huh. Interesting. Okay. Hold on a minute. I gotta do some testing here. Huh. Okay. Interesting. Okay. I guess it's Hold on a minute. I gotta do some testing here. Huh. Okay. Interesting. Okay. Whatever. It works so far. I'm gonna keep an eye on the little thingy there that shows that audio's going, and I'm assuming it works until then. So teach me to wait till the last minute to uh, do the stuff. I just had family stuff going on and just couldn't do it. Couldn't get to. Okay. Okay. Audio should be working now. Trying to do this on the fly. Ugh. Okay, let's go. Let's do it. All right. So we have Tokio main, and we have this on the main function, and it should be working. Should be able to run this. We really want to do a wait. How did it do it over here? So let dot await call the stuff. Okay. Now what we want to do, undo this. What want to do match. Yeah, get hosts dot await. Okay. Print hosts. No, okay. I just want to I don't want to print hosts. I guess I do actually. Let's do a function print hosts. Back hosts is what it's expecting. Let's kill that. Let's do that. Let's just just for the sake of argument, we're gonna do that. Cargo build. Yeah, this thing is not happy. Okay, candidate version found didn't match to application crates took. If you're looking for a pre-release package, it needs to be specified explicitly. Perhaps a crate was updated and forgotten to be revendered. Oh my gosh, I have no idea what's going on. Why? Okay. These are the struggles. These are the struggles. All right. The candidate version found, which didn't. I wonder. Maybe if we update Rust. I actually totally guessed on that, but that felt like what it should be. Let's see, cargo version edition. Rust version. Okay. Something is messing up with Rust. How can I set in my Tokio, my cargo.toml to the latest version of Rust? I'm hoping this will give me kind of an explanation of how to using the Rust up and the Rust toolchain files. You can specify a Rust version for your project by creating a Rust toolchain or a Rust toolchain.toml. Channel stable, updating Rust up.a. This command updates, checking for minimum required Rust version. While you can't specify a Rust version directly, you can use the Rust version field to specify the minimum required version for your crate. This doesn't enforce the version, but serves as information for your users. You can't directly set a Rust compiler version of Cargo using Rust up and the Rust toolchain.toml. File provides ways to ensure that I should be using the latest. Okay, I just saw Rust version. For library creators, the Rust version field in the cargo.toml can help. Okay. I know this is total sidetrack. But what is the addition? What is the addition in the cargo.toml? The addition field in the cargo specifies the Rust addition that your crate is written to be compatible with Rust. Rust additions are a way for Rust to introduce significant new features and improvements without breaking existing code. They act as milestones, blah, blah, blah. Okay. The latest is 2021. So we should be using the latest Rust. So cargo build. Let's just see. Okay. Failed to select a version for the requirement Tokio macros 2.2.0. Candidate version found, which didn't match. Oh, okay. If I would reread this like 5 times, it makes some more. Okay. Version. Okay. What? So let's go with Tokyo. Let's go to GitHub. Look at issues. Tokyo macro. Okay. Did not help. That's just weird. Cargo.tom, just out of curiosity here. Tokyo macros. What is it? Okay, there we go. Tokyo macros. Why is it rendering? Like, what is going on? What's this? I have no idea what's going on. Okay. Version 2.2.0 edition that Rust that proc macro 2. I mean, what? So we go back to here. Let's go to Tokyo macros version 2.2.0. That was released 5 months ago. Okay, I thought I knew what this meant, but apparently I'm stupid. What does this mean? I thought it just couldn't find the right version. This error message requires package manager, but it indicates problem with dependency resolution in your Rust project. Let's break it down. Failed to select Tokyo project or one of the dependencies requires Tokyo macros crate with a version requirement of approximately 2.2. Yeah. Canada versus Palestine, right? Cargo found versions of Tokyo macros available of 2.10, but none of these meet required packages. But we just saw on cargo that there is a 2.2. And then I'll bet if we go back, 1.36. If there's a version 2.2 or above, updating your cargo.lock file might resolve this issue. Cargo up. Okay. Cargo update. Updating regex, procmock. What? Adding all of these. Tokyo macros version. Okay. Okay. Now cargo build. Interesting. Oh, okay. I bet I know what happened. That sucks right there, but let's ignore that. Okay, so I bet what happened is, and it actually makes sense, is I installed I installed Tokyo. I knew what features I needed, figured out what features I needed. Then I did the cargo add with the features, and then I didn't do a cargo update to make sure the cargo.lock and the other stuff was updated properly to the correct file. That makes total sense. Okay. Yeah, and these are the things that you learn. Like these are the moments that are important for learning is like you make these mistakes and you try to figure out what's going on. So now I know for the future that I need to do the cargo update as well after I modify the features. All right, now let's go to here. All right. Mismatch types. All right. They're all mismatched. Not calling an async function returns a future. Right. Right. Are correct. Okay. We have got to kind of reapproach this a little bit. Oh yeah. I think we do a way. Oh, it looks like Vim is working now. I mean, okay. Okay. Nice, nice. This expression has type vec host. Line 75 in main. 75. Okay. So when we call host and we call it with a wait, we're actually getting back vec of hosts. In this case, I don't, yeah. I was kind of being a little ambitious here. I think I would do that and save. Okay, dot await, and then print hosts. Cargo build. There we go. Cargo run. So at this point, it should be running those things side by side. Uh, but it's still calling each IP address one at a time. Yeah, so, I mean we're still doing good. We're still doing good. So yeah, look, I mean we still got MAC addresses, we have IP addresses. This was an ARP only or an ARP only return, another ARP only. So yeah. Okay. Next, let's go back in Vim source main. Before I jump into this, I want to print line. That's fine. Let's go with print line. There we go. All right, now let's cargo run. Yeah, I mean, just look how fast that's like just jamming it through. Should be 31 hosts again. Yeah, so this is definitely going faster. 32 hosts this time. No. Was there? 31. Okay. I picked up one somewhere. Cool, cool. All right. So we're doing all that async. Now let's get more interesting. Now let's create an async get host. I want IPv4. Yep, and we want to return a host. Okay. So all right. This is where concurrency is fun because you gotta like change your brain a little bit. And when you're so used to like you've done this project and you're doing it synchronously, and then you have to change your brain to think asynchronously, it's like okay. Really what we want to do, I mean, we do need to loop through. So what I want to do, so if I was in Python land, I would want to basically create a task for the get host and get all of the host, like, and just have it go blam, and then wait for every task to finish. Then I would finalize each of these. Like, that's kind of the cheapest way to do it. Really what I want to do is here's what we want to do. We want to do, because like it's kind of stupid to do that check down here. So let's do, was it option post return sum, and then let's do, take this, and this would be return none. Okay. So then I want to, okay. Let's kill this. No, I still want to do this. Okay. Trying to think through. This is where this is where the rubber meets the road. This is where the learning happens. Okay, with Tokio, I want to call an async function. With Tokio, I have a vec. So I'm not going to feed it my code of U8. I want to call a function. I want to call an async function that takes a U8, does some stuff, and returns back another U8. No, a U16 because I'm being awesome. That was really stupid of me to say. And when it returns back a U16, I just want to return a different type. How with Tokio do I get all of the values from U8, call the async function, then wait for all of them to be done, and then proceed with the rest of the call of the function. We'll see if this gives me out what I want. All right, to achieve this Tokio, you can use futures. Yeah, crate. Oh, which is often used alongside Tokio for working with futures. And it's future join all. Okay. This function takes an iterator. Crap, it's going away. It's going away. This function takes an iterator of futures and returns a single future that completes once all futures in the iterator have completed. The result is a vector of the results. Wait, crap. I lost my place. The result is a vector of the results of each individual future. Right, okay. First, make sure you have the Tokio and futures crate in your cargo.toml. You might have already, yeah. Okay. So let's do futures. Let's do cargo add future or futures? Futures. Okay. There we go. And then we want checking our coder settings here, but recommended too. I don't know what that means. Okay, I'm not gonna worry about my. I'll look at that later. I'm not gonna worry about my OBS or restream. Okay. Just out of curiosity though, real quick, new format. Yo format. Interesting. Do I have Rust FMT? Rust FMT. FMT. Ooh. Deprecate. Deprecation should now be installed via Rust up. Interesting. Figure that one out later. Okay. So now we have our vec. That's kind of what I was thinking. Like out. So we want a futures and task spawn. Oh, we want a Tokyo task as well. Okay, okay. Use Tokyo task. Okay. So we want to do let's, is it mutable? Futures equal, yeah, there we go. Map the IP, so the reference, task spawn async move process item, so in this case get host IP data wait, yeah. And the dot collect is called after the collect. Okay. Okay. So in this case, it's interesting. Into iter, it's doing a vec into an iterator, and this is just doing. Wait, what is IPs? IPs is a vec. Returns an iterator over the slice. Iterator yields all items from start to end. So what if I did into? Creates a consuming iterator that is one that moves each value out of the vector from start to end. The vector cannot be used after calling this. Interesting. Interesting. It's a good question for later. Why into iter over iter? Let's just come back to iter. Then we're mapping into a closure. Yeah, I don't understand that line. Let's just do that. Dereferencing the borrow. Oh, okay. What IP? Okay. Async. I don't understand. I need to learn the move. Oh, okay. I think that's a move from the borrow checker. Supposed to wait. Okay. Now we got them all. Now let results equals join all future dot await. Dot think. Actually, let's do a print line. There we go. I'm gonna leave the mutable there. cargo build. That's fine. Cargo run. Slam! Look at that. Like, that was intense. Did you see how fast that went? Man, I just slammed my network. Interesting. Okay, so what it looks like in the results is each result is returning a result that we need to work through. So let's do an into iter because we don't need it. Filter map creates an iterator that both filters and maps. What? Okay. Okay. So I think we do that. Collect transforms an iterator into a collection. Try wrapping the expression in sum. Thought it should already be a sum. I don't think we got any better. We didn't get any. We didn't get any better. It didn't help us any. Did I? I didn't save it, I don't think. Let's just see what happens. Okay, into iter. That's what I want. I want a vec at this point of option host. I think is what I want it to be. I did. I did surround it. Oh, actually, I don't. Do we want? Okay, we get a little closer. We're a little closer. We have unwrapped. Okay. Cool, cool. Okay. So with that in mind, uh, So yeah, so we have unpacked it to an unwrap, and okay. So yeah, we've waited, gotten all the results. You know, lazy way out for the moment. Let's do, yeah, let's do that. I like it. That's the lazy way for the moment. Uh, let's cargo run it. Boom. Output 32 hosts. Um, I'm gonna get logging in so that I can like turn that off and on. Cargo run. Boom. Look at that. Look at that. How cool is that? Look how fast that went, and it didn't even like I didn't have to hit the database. That's pretty darn cool. Do it again. Boom. I like it. So yeah. So with that, we have successfully added Tokio. Take that away. I'm still a little shaky. I mean, so what we did is we abstracted. We did a little refactoring. We created our main function with Tokio main so that it creates the thing, the environment for it to run. Then we abstracted out the core piece to get a single host, and we're returning an option host, so none or some. And then we changed our get hosts to use the join all from futures. And what that does is that takes and maps all the IPs from our CIDR rule and uh, calls them all individual, like just splays them all out, and it hits the entire network all at once, pretty much. Then it collects. So this collect is not a collect of all the results. This collect is just saying, hey, get all of the tasks and get them ready to go. I wonder if. So one thing I'm curious about is if so if I do this, I'm pretty sure if I do this part in Python, it doesn't actually call the code until I await the result. Uh, or it might. There's something that I was messing with that just by declaring it, it doesn't actually run it. But only when I go and look for the result does it actually. It's a lazy execution of the task. So I wonder. Yeah. So yeah, it totally same thing. That's true. So it created all the tasks. I think it's in because you can create all the tasks, but until you execute them, it doesn't do crap. And so in this case, we're just saying, hey, create the task container that we want to run, and then with this line, we're saying actually execute them all. Yeah, the return future will drive execution for all of the underlying futures. Yeah, so this spawns a new asynchronous task returning a join. This provided future will start running in the background immediately when spawn is called, even if you don't await the return. So you have to call spawn. Spawning a task enables the task execution concurrently to other tasks. The spawn task may execute on the current thread, or it may be sent to a different thread to be executed. The specifics depend on the current configuration. Yeah, so, ooh, what was that? Ooh. Come back. Come back. All right, in this example, it's doing a TCP stream listener. So we're going to async process, create a main, we want an IO result, we're going to bind it to 8080 and then await. And then as it accepts a new thing, it's going to spawn an async task. And yeah, that's going to take it out there. Okay, cool. I like it. I like it. All right. So we verified my supposition. One thing that I would like to do is, I don't know, can you just not return with a map? I mean, it is doing, so enter.map 2 times x. To a 4. However, a map is lazy. It's best used when you're already working with other iterators, if you're doing so. I mean, do you need to return something? Map transforms one iterator into another. This produces calls as closure on each element of the original iterator. Yeah. Okay. Okay. Here we go. Here we go. Let's try something in here. So let's do this and oops, and this and this and this and this and match X. Okay. So what I want to do is just, oh, error none, but I don't want to return none. Just want to print line error getting host. There we go. Can I just do, I feel like I have to return something for the map, and that's not going to work. Let's undo here. Let's come back over here. I want ChatGPT for this line. Do I need to return something for use with a map? In the case of the option host, I just don't want the final result to have a result. Like, part of me feels like you can't do this because you need something because you iterated over it. I don't want the final result to have a result because it is none. So if I have an iterator with 200 elements and only 30 have a sum result, then I want the final result file output of the iterator slash map call to have 30 elements. Let's just see how ChatGPT does that one. We can use a filter map method instead of the map. The filter map method allows you to both, oh. The return iterator yields only the values for which the supplied return sum. Yeah. Yeah. All right. Yep. It is. There it is. There it is. That's exactly what I want if I would have just kind of gone with the flow. But I learned whoops, we make mistakes and when we don't get the results that we want, and we learn from those. And that is how we do it. So in this case, we are getting the IPs. We're spanning them, spawning them all, spawning them all. And then we're awaiting. And then in the filter map, we are unwrapping the result return type in the await of in the join all await. Anyway, it came back as good, so we're unwrapping it. We're assuming it's all going to be good because this is an app for personal use and we don't care. Then we're collecting all of those results that actually have a good return type because we were fortuitous, and in line 34 we decided to use an option host. And then so that way when we used filter map instead of map, then we only get the vec hosts that we want. And so now we're in a better position. We have successfully asynchronized this whole thing, and everything is now faster. So now that we have this here, we're calling it, we can move on. So in this case, we can either print the hosts or we can move on next week, and we're going to write the results to a database, which is cool. We're getting there. We're getting there on this neat little tool. Yeah, so stick around, and the next episode we'll do the database side and hopefully the command line side. Then we will swing back and do the notes for it. And then I think from there, I might skip number 5 for a few weeks because I want to move on to another couple projects, just to kind of, one of them is just kind of a practical thing I want to make. And then the other one, I don't know how long, it's probably going to be a very long-term project to help with some learning. But I want to get this basically in a better position first and go through some better code organization and just clean it up. I think where we're at currently, minus number 5, I think once we're done with all of these steps, minus number 5, we're going to cover all of the areas that I wanted to accomplish with this project. So probably a couple more weeks, 2-3 more weeks, and we'll be ready to move on. I'm enjoying it. I'm having a lot of fun. I've learned a lot, and I'm getting better. So that's the good thing. So with that in mind, I thank you for watching. Sorry for all the technical issues. I should hopefully have less next week because hopefully I will have learned my lesson. So with that in mind, thank you, and I will see you all next week. Now